This video is how this video will show you how to develop your own strategy for the Chem Phys section of the MCAT. Before we get started with strategy, let's talk about what the Chem Phys section even is. So it's technically called the Chemical and Physical Foundations of Biological Systems. And of note, it's not just chemistry and physics. 25%, so between 20 and 35%, on average 25%, is going to be biochemistry. 0 to 10%, about 5% on average is going to be bio, about 25 to 35, so 30% on average is going to be gen chem, about 10 to 20%, so about 15% on average is going to be OChem, and about 25% on average is going to be physics. So almost 30% of this exam on average is going to be about bio and biochemistry, having nothing to do with Chem Phys. And that is pretty significant when talking about this test. So you should not just be preparing for chemistry and physics and think you're going to be good for the Chem Phys section. You also need to be really understanding how biochemistry and some intro bio work. However, even just learning the content isn't enough. The questions are not just based on your content knowledge. Although those are the topics discussed, there are 4 main ways in which those questions are presented, and those are referred to as scientific inquiry and reasoning skills. There's going to be knowledge of scientific concepts and principles. That really is testing the content straight out, asking you questions, and you need to understand if you know what an acid or a base is straight up. There's also scientific reasoning, problem solving, as well as reasoning about design and executive research and database and statistical reasoning. If you notice, reasoning is mentioned in 3 of the 4 types of questions that can be presented on the MCAT. And so content knowledge, content mastery is going to get you 1 out of the 4 types of questions. Each of those questions is not showing up equally on the MCAT. We'll get into a little bit about that coming up. But recognizing reasoning beyond just knowing content, you have to be able to reason the content that you understand, is a massive test on the MCAT itself. As it relates to the Chem Phys section, the knowledge, the content knowledge is going to be about 35% of this section on average. It's going to be testing that content via words, graphs, tables, diagrams, or formulas. And so this is where understanding, oh yeah, I do know kinematics equations. I do know how to calculate acceleration. That's going to be a straight out tested within this. Also, we're, like I said previously, testing if you know what an acid or a base is. There's also going to be some testing of if you know and can recognize like competitive inhibition, for example, by being given a graph about it, where you have the Km and the V. There's a lot of different things that can be tested in all of these different formats, but all of this is content knowledge. It's not going to be doing reasoning. It's just explicit content knowledge. After that, you've got about 45%, which is the scientific reasoning problem solving. So the 35% is straight content. That means about 65% is not straight content. It's some kind of reasoning based on the content. The majority of that is going to be scientific reasoning problem solving, where they're going to give you pictures or diagrams. Sometimes they'll give you equations, and you have to look at those and draw conclusions based on that. It's also using a scientific formula and figuring out which scientific formula you need to use in the first place to be able to solve some kind of problem. And a lot of this types of questions is where your math skills come in. So being able to do conversions correctly, being able to understand delta G, being able to do basic calculations with physics, using the formulas to solve the problems, but really identifying which formula you're having to use in the first place. So this is also figuring out the type of graph. So is this a semi-log plot? Is this a log-log plot? Is this just a linear graph? Is it a linear log plot? Being able to understand all the different graph types, identify based on the scale what type of graph it is, and know what to interpret or reason through based on the graph that's given. There's also where some trig is going to be tested. To get a better understanding of the math skills that are going to come in, watch the SIRS overview video, which is linked in the description below. After you get through that 45% chunk, the massive chunk of this section, one of the other types of questions is reasoning about design and execution of research. So understanding how to complete, conduct, and evaluate, analyze research is a massive concept that is both tested on the MCAT and required of you to be an effective physician. A lot of the way you're going to be treating your patients is based on the most updated research. So understanding what is good research, what is bad research, analyzing and evaluating good and bad research is of the utmost importance to be able to treat your patients effectively. And so it is something that is absolutely going to be tested on the MCAT. So this is going from all the way from formulating a hypothesis to making the conclusion. So if you remember the scientific method, each step of the scientific method could be analyzed and assessed whether or not this was an effective research design. It's also seeing if you know what assumptions are being made based on their hypotheses, what inferences they're being made, and what other further research can be done if based on their conclusions. So for example, if they concluded that children under 5 years old are all below 6 feet tall, further research could be on how tall the average 2-year-old is. It could also be on how tall the average 4-year-old is. But extending that research based on what you've already done wouldn't really be relevant if we're trying to figure out, okay, people under the age of 65 are mostly under 6 feet. Comparing children and adults are completely different things. And so that wouldn't necessarily be further research you could do based on the research that was done currently. So being able to figure out what research can be done based on the assumptions and the conclusions that you have made so far. This is also figuring out the relationships among those variables. So do you know what the independent variable is? Do you know what the dependent variable or multiple variables are? Are you able to understand the relationship between the two? Which of these did they have to hold constant in order to be able to change something else? What are they actually testing here? Knowing which is independent and dependent, both based on the graph that is presented to you, as well as the way the research is described to you. Then the last 10% is going to be data-based and statistical reasoning. Yeah, this tends to be my favorite. I love statistics. I'm completely being sarcastic. I do not enjoy statistics. I recognize that it's helpful for analyzing research, but not my jam. And so these are the types of questions that I tend to be like, whatever, I don't care, not about to do this. But it is about 10% of this test. And so this isn't something you can always just throw away. This is where you're interpreting the results of those tables, charts, and graphs. So recognizing the p-value, is it going to be significant, not significant? And that's also based on the error bars. And it's also based on the confidence intervals. So being able to understand what each of those things are, how they relate to your ability to interpret the data that you have in the first place is going to be very helpful to be able to answer these types of questions. It's also identifying patterns in data, so recognition of patterns and conclusions based on those patterns or based on the data, based on the evidence that you're given, knowing what conclusions you can and cannot draw, similar to being able to understand what further research can or cannot be done, know what conclusions you can draw based on the data that you have been receiving. And so now this leads into building your own strategy. I previously talked about how statistics is not my jam, not my favorite. And so whenever I have a statistics question on an MCAT, I'm just assuming I'm not about to do that. Don't even try it. Just move on with my life. That's a strategy that I know I can embrace because there are enough other questions on this section that I feel comfortable and confident being able to answer. You have to come to that conclusion for yourself. Every student is going to be different in terms of what questions they're going to answer and not answer. Every student's going to be different in the number of target questions that they need to answer. So for example, on the Chem Phys section, there's 59 questions in the section, but you don't need to answer 59 questions in order to be able to get a competitive score. You don't even need to answer 50 of the 59 questions in order to get a competitive score. If you're trying to get a 500, I advise students to start by getting 35 questions that they know in the bag, that they know they're going to get right every single time. They feel very comfortable, very confident, and in increasing their pacing on getting those 35 questions. You're not going to be able to answer 40 questions until you've answered 35 questions. You're honestly not going to be able to answer 35 questions until you've answered 25 questions correctly, consistently. So the goal is to eventually get to about 35 if you're trying to hit that 500 score. But how many you actually answer is going to vary based on what your actual target score is and where you're starting. If you're starting by getting about 17 questions correct, don't give yourself a goal of getting 35 correct next time. Give yourself a goal of about 20 to 25. Start slow, work in increments, and build your way up. There's going to be a whole lot of mistakes that you're going to be making as it comes to preparing for the MCAT. And so there's going to be a lot of different things that you're having to fine tune, switch up, eliminate, embrace as you're developing your strategy more and more in depth. So off top, recognizing 35% of this is content-based. So a lot of students feel, I just need to review more content. And 35% of this test is based on your understanding of content. The rest of it is how do you apply the content that you may or may not know. But this is a multiple choice test. So there's always going to be some things that are correct and some things that are not correct. Can you figure out what's correct, what's not correct based on what you're consistently doing right or wrong? Or is this just the type of question that you need to throw away every single time? Figure that out for yourself. So understanding that you need to do reasoning based on your content knowledge for majority of the questions. And that requires application of the content. So most students get really frustrated once they've reviewed content for a little while because they're recognizing, okay, but I know this content. Realize that question was asking about this content. They didn't say that. Why didn't they just say that? And a lot of the times when you're working with patients, they're not going to just tell you what their diagnosis is. You have to figure that out based on certain clues, context, understanding of their situation. And so you have to reason. Reasoning is a massive skill that's required to be a physician. So recognizing it's not just explicit outright. What is going to be delta G if this is delta H and this is delta S at this specific temperature? Or what is going to be the gravity on Jupiter at 1700 hours, May 5th, 2085? Like, those are questions, yeah, you might get in a physics class or in a chemistry class, but you're rarely going to get those types of questions when it comes to reasoning on the MCAT. It'll be more like, okay, gravity is going to be different on Jupiter. Is it going to be bigger or smaller, and why? And recognizing, okay, well, based on the size of the planet, based on how far it is compared to the moon, compared to the sun, compared to all the other planets, what are those gravitational pulls going to do? So what is gravity actually going to look like on Jupiter? That's applying the content, even though you have an understanding of how gravity works. And a lot of times these questions take more time. That goes back to, don't be out here trying to answer 59 questions. You do have a limited amount of time, and this is about you making the best use of the time that you have given, not spending the same amount of time doing everything, because you're not trying to be everyone's physician. You're trying to be a physician for a specific type of person or in a specific field or a specific specialty, and that's the stuff that you got to capitalize on. If you're trying to go into pediatrics, maybe you don't need to understand adult neurology or how the adult brain works. So figure out what you need to know, figure out from there what you need to improve upon, and build your strategy. So the first question to think about when you're developing your strategy, should I focus on my strengths or weaknesses? I mentioned previously that a lot of students get stuck trying to review content and then recognize that reviewing content isn't helping them understand or get more questions correct in the first place. So at this point, would it be more beneficial for me to focus on those strengths that I have, learning that content more, learning how to apply that content more? Or should this be where I'm focusing on my weaknesses? Are there areas of content that I don't really understand that I want to get better at? And how do I improve on those topics? Understanding that your strengths might not just be in content. Your strengths could also be, I'm really good at narrowing it down to 50-50. Once I get to 50-50, I'm always stuck. My strengths could be, I'm always able to identify the types of questions that would trip me up, and those are the questions I never choose. Figuring out what those strengths actually are, then identifying those weaknesses. And as you go through this study process, your strengths and weaknesses could change a whole bunch of times. Don't be bound to, I'm really good at biochemistry, and then you have one test that's a whole bunch of application of biochemistry and you don't know how to apply biochemistry at all. That doesn't mean you're bad at biochemistry. That means you need to have a better understanding of what about those questions is complicating it for you. Once you figure out what your actual strengths are, how many questions are testing that strength? Again, try to start with a goal of about 35 of those questions. So figure out if you're trying to get to that 500 score. So if you're trying to aim for 500, are all of my strengths getting me to 35 questions? If they're not, you got to assess, what do I need to do more? Am I needing to increase my accuracy on my strengths? Am I needing to increase my accuracy on my weaknesses? And if you recognize, okay, I'm going to have to do something about my weaknesses, which weaknesses are going to be the easiest for you to address? If you recognize your weakness is in doing scientific notation and being able to do some of those conversions, that's something that you could address by doing a whole bunch of calculations for practice. However, if you've been doing math for 15, 20 years and you've never gotten good at calculations, you might have such a bad experience with math and a bad relationship with math that it doesn't matter how a math question is presented to you, you're going to get it wrong. And that's something that's different to address. It doesn't mean that it can't be addressed, but it means you're going to have to do more of the emotional work, not the actual work. And that's the thing that most people try to avoid, not even just on the MCAT, but in life in general, is I'd rather the problem be your problem than be my problem or something internally that I have to work on, because that's a lot of effort and energy. But this is really the space for you to be honest and open with yourself about what are the big issues. Am I just covering over my issues, or am I willing to engage, dive deep into my issues and address them to improve upon them? You don't have to address every single issue. Let's be real. You just need to address enough to be able to get you through this test. So figure out what you want to do, what you don't want to do. After you've done the initial assessment of your strengths and weaknesses, the next question you got to ask yourself is, are those really your strengths and weaknesses? So you do a practice test. Okay, I've assumed I'm going to be attempting these 35 questions. Once you attempt those 35 questions, if you're getting 17 for 35 right, those are not your strengths. If you're getting 33 for 35 right, those are absolutely your strengths. So if you thought these were your strengths and you're like, well, actually, those are my weaknesses, then that's something else for you to address. But this is a lot of trial and error where you're going to be making a lot of errors. And the biggest improvement you can make is learning from your errors, not deciding your errors are a reflection of your incapacity to do this in the first place. Maybe you might surprise yourself and be better at your weaknesses than you thought you were. If you had 24 weaknesses questions and you're getting 16 of those right, those aren't actually your weaknesses. And that might be because you're really good at guessing. That could be because you actually address those questions. Whatever it is, figure out what you need to address and change, shift, whatever, based on your practice exam of what you thought were your strengths and weaknesses. And from there, how do you redefine what your strengths and weaknesses are? How do you need to adapt? If you recognize, okay, I'm missing 20 questions that are all about conversions, and I know I'm only missing conversions questions because I have a bad relationship with math, because I had one teacher when I was in 7th grade who said that I was going to be stupid just like my great-grandfather. That's something different to be addressed that needs to be adapted. And that's where you really have to have a moment of like, I'm not about to let that one experience keep me from getting 20 questions correct just because I get into this emotional space. I'm going to take the time, go actually address how that makes me feel, why it makes me feel like that, what strategies I can develop to help myself not get into that feeling, but allow myself to stay focused on just doing the question itself and then move on with my life. That's just one example of something you might need to adapt. That isn't, I need to go read more books. And then the last question, are there easy points that you're missing? So other than the content, what other things are preventing you from choosing the correct answer? Are you missing things in the notes? Are you needing to slow down? Are you needing to speed up? Are you taking too much time to think about this question and then you're second guessing yourself? Do you need to do practicing of conversions without a calculator? A lot of students get really good at doing conversions because they're allowed to have a calculator. And then the second the calculator is gone, the issues come up. So do I actually just need to get more comfortable not using a calculator? How do I do that? Or is it something else? Be open to all kinds of options as to why these might be your challenge. Other things to keep in mind, what is a K? Just generally, if you understand like a K is a constant, that's products over reactants, no matter what you're doing, are you able to understand and eliminate certain things just based on, okay, well, this is not how a K equation would be set up ever. Understanding what is K in the first place. Read the notes and the label on the figure. A lot of times students will draw a conclusion based on figure 1. The question's asking about figure 2. Did you read? Are you also looking below where they have that little asterisk where they have the note and they talk a little bit more about the description? Did you read that note? Sometimes that note is the difference between you getting the answer correct and not getting the answer correct. When they give you an equation in words, but they don't actually write that out in like the chemistry form of an equation, write out the equation for yourself and make sure it's a balanced equation. So then you're able to have a better understanding of, oh, 2 molecules of this leads to 1 molecule of this. So it's a 2-to-1 ratio. It's not 1-to-1 like I was thinking. Be able to balance those equations for yourself. And lastly, compare and contrast molecules. If they give you a molecule and then they say that this molecule becomes this, figure out what changed from the first molecule to the second. Oh, an OH group was added. That means that it had to be some kind of nucleophilic. So what other things do you need to understand based on that? And use this to eliminate answer choices. Okay, both of these answers say that there should have a 2 ring, and this answer or this molecule only has 1 ring. So it's neither one of these answer choices. Be able to understand how to find differences in the molecules. Little differences make a huge difference. And of last note, apply the concepts of physics without logic. So a lot of times physics concepts are just a concept, and as soon as you start thinking logically about it, the concept breaks down. But as long as you stay with just the physics concept as a concept, don't try to add your own logic to it. Okay, well, I know if pressure goes up, volume goes down, no matter what the situation, you can apply that to every single question. And the MCAT is not really testing your logic of those questions. It's testing, do you know how to apply those concepts just outright as a concept? Similar to, do you know how to do research? It's not based on what you think the research should be. This is how research is done. Do you know how to follow instructions? Hope you found this informative. Have a good day.